we are almost at the last segment of this chapter. We have seen the determination of the molecular masses in the past one or two classes. Now, the last segment of this chapter consists of this topic, chemical equation, its balance and stoichiometry. In this particular portion, we have to understand how the chemical equations are written, what are the importance of that equation, because chemical equation we used to write from junior classes also. Here we will have a chance to revisit at those concepts. Here we are going to understand that what does a chemical equation mean, what are the essentials of that, and from a chemical equation, this particular term stoichiometry, this one will let us know that if a chemical equation is balanced, it's how many moles of reactants are reacting with each other, how much products will be formed, and based on that, for each individual species or reactants, how much is actually required based on the other species. Suppose there are two species, one is depending on others. So all these things will be discussed in this particular section. It is easy, but as I have said, it's a revisit to the concept that we already have. Now, let us start the discussion. In the beginning of this discussion, we are going to understand how to represent a chemical equation, which is very simple, nothing new. So first we are going to talk about the representation. Representation. Very simple. We all know that whatever is on the left hand side of a chemical equation is known as the reactant. So let me rewrite that. Suppose we are writing A plus B giving rise to C plus D. We all know that these are reactants, and these are products. So reactants and products we have mentioned. Now the point is, if I am writing AA and BB and small c and small d over here. So A and small a and small b are called molar coefficients. These are called molar coefficients. Obviously, this is for reactants, and C and D, this is for molar coefficients of products. So, needless to say, if I am writing Zn plus HCl gives rise to ZnCl2 plus H2, I have to make sure that it is balanced. Balanced means I have to make sure this particular point, we have to write down it in molecular form. Molecular form. What does it mean? Molecular form means the number of each things will be written in the molecular form itself, not in the atomic form. For example, I cannot write H plus H. This will be the atomic form then. So I have to write that in the molecular form only. Now, as a matter of fact, it has to be written H2. Now let us see whether it is balanced or not. Balancing is important to understand the stoichiometry. How many moles will react with how many moles? See, there are two chlorine only and there are two hydrogens, so it should be 2. So from here, we will understand that the zinc is in 1 mole of zinc is reacting with 2 mole of HCl. Further to say, from here only, if we further discuss, we should be able to write that suppose we know the atomic mass of each of every one of these. So in this case, what we can say is zinc is suppose 65.3 gram. 2 HCl. Hydrogen I think is 1 and HCl is 35.5. So 63 gram zinc reacts with, carefully see HCl, I am recalculating, 1 into 1 plus 1 into 35.5 and it should be multiplied by 2. So it is, as you can see, 36.5. So we should be able to think that it is 36.5 into 2. So it is basically 73. So reacts with 73 gram of HCl according to the given equation. So this part is very, very important. That how many moles are going to react with how many moles. So from here we are having this weight ratio. We are able to say this weight ratio if we know the molar ratio only. Now let us talk about few such equations. So let me erase once again. Let us see the equations now. Very well known few equations we are going to see. Initially we are not going to go into the complicated terms. Let us see the equations given by N2 plus 3H2 giving rise to 2 NH3. Here clearly we can see it is 1 mole, here also it is 3 mole, and here it is 2 mole. Further to say, we should be able to write that 1 mole of nitrogen, that means it is, as you know, nitrogen, that is 14. So 14 into 2, this is 28 gram of nitrogen reacts with 6 gram of hydrogen and giving rise to, say, ammonia quickly. 14 plus 3 into 1, right? So it is 17. So 2 into 17, that is 34 gram of ammonia. So 28 gram of nitrogen, 6 gram of hydrogen, 34 gram of ammonia. So this is the scenario. So now based on this, what we should further able to say that it is 1 volume, it is 3 volume, and it is 2 volume. If all of them are gaseous, then we should be able to say that 1 volume of nitrogen plus 3 volume of hydrogen gives rise to 2 volume of ammonia gas. Furthermore, we can say that it is 22.4 liter of nitrogen plus 3 into 22.4 liter of hydrogen gives rise to 2 into 22.4 liter of ammonia gas. So this is how the concept will be built up. One more line we can say further, that it should be 6.022 into 10 to the power 23 number of N2 molecules. It should be 3 into 6.022 into 10 to the power 23 of hydrogen molecules, and giving rise to 2 into 6.023 into 10 to the power 23 number of ammonia molecules. So this is how we should be able to understand. If you cannot see, just let me adjust the camera once again. Okay, now I think it is visible. So this is how we understand the concept of the stoichiometry reaction, its relationship with volume, its actual volume in STP, and its number of molecules that is reacting with each other in this particular case. So qualitatively and quantitatively, in both the cases, we have understood how a chemical reaction will give us so many informations. So let us see what are the outcomes. Outcomes we have seen. In the form of data. Now let us see it in the form of topic only. So two aspects. One is qualitative. Qualitatively, what it gives? Qualitatively, it gives us the names of reactants and products. But quantitatively, if we see quantitatively, it gives the relative number of molecules, relative number of molecules. Secondly, it is relative masses. Third is, we can also say the relative volumes. Fourth one, we should be able to say about limiting reagent. What is this limiting reagent? That is what we are going to discuss next. So our next topic is the discussion of limiting reagent. So let us see. So let me erase once again. We will talk about limiting reagents. So here we are talking about limiting reagent. While discussing limiting reagent, let us first define. The limiting reagent can be defined as the reactant which is completely consumed during the reaction. The reactant which is completely consumed during a chemical reaction, because on that particular case only we are talking about chemical reaction. Now, suppose let us talk about hydrogen, this reaction, 2H2 plus O2 giving rise to 2H2. So obviously it is of 2 mole, it is 1 mole and it is 2 mole. In the above case, you can see the hydrogen is limiting reagent because see 1 mole of oxygen is required for the completion of reaction. So 1 mole of oxygen therefore in this particular case, if we take, say for an example, if we take 2 mole of hydrogen and 2 mole of oxygen. But from here we can see it is only 2:1 ratio. So actually 2 mole of hydrogen is needed for 1 mole of oxygen. But here we have taken 2 mole. So from here 1 mole will be excess. 1 mole will remain excess. That is why in this case, if we take this amount, this much will be limiting reagent. This amount of hydrogen will decide whether this particular chemical reaction is going to be finished or not. When the hydrogen will be finished, the reaction will be finished. So let us see one such problem regarding that. So let us see one problem. So let me erase once again. First you write it down. Let me erase now. Let us see it in form of numericals only. Here the question goes like this. 50 kg of nitrogen. 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce of hydrogen are mixed to produce ammonia gas. Calculate the ammonia formed. Calculate the ammonia formed, and at the same point of time identify the limiting reagent in this situation. Identify the limiting reagent in this case, in this reaction. So let us see how it can be solved. So for the sake of our discussion, this is obviously mandatory. N2 plus 3H2 giving rise to 2 ammonia. Here it is 1 mole, 3 mole. So here we also know that there are 28 gram of ammonia. Then it should be 6 gram of hydrogen giving rise to 34 gram of ammonia. Sorry, 28 gram of nitrogen, 6 gram of hydrogen gives rise to 34 gram of ammonia. Now, according to the question, you have been given 50 kg of nitrogen. So we have to find out, calculate the ammonia that should be formed. So out of these two, you see 6 gram of hydrogen is required for 28 gram of ammonia. So let us see first. So for 28 gram of nitrogen, we need 6 gram of hydrogen, right? For 50 kg of nitrogen, for an example, for 50 kg of nitrogen, so here what we have to do is, in this particular case, since one is in gram and another is in kg, the best way to do is to find out the number of moles that is present. So first thing, that is what we are going to do. So first is number of moles of nitrogen, how much is present. So obviously it should be, here you see it is 50 kg. 50 kg is already given. It is multiplied by, as you know, 50 kg, if you have to convert it to grams, so it will be multiplied by 1000. Obviously we are converting it into grams, divided by 28 gram. So as a result, over here we are getting 17.86 into this much of 10 to the power 2 moles. Similarly, if we are trying to find out number of moles of hydrogen, it will be 10 kg, in this case 10 into 1000 divided by, as you know, in case of hydrogen, the one hydrogen is how much? Here, over here you can see it's 2 only. So this is how it is. We should be getting as 4.96. The value that we are getting is 4.96 into 10 to the power 3. So these two values we are getting from 50 kg and 10 kg only. Now, the role is to understand that if 1 mole reacts with 3 mole, according to this, how much of nitrogen will react with how much of hydrogen? So, therefore, we will calculate now. So here, what we will do is, So according to the question, here I am writing that 17.86 into 10 to the power 2 mole of nitrogen will react with so 1 mole of nitrogen reacts with 3 moles of hydrogen. So it will react with 3 into 17.86 into 10 to the power 2 moles of hydrogen. What is the answer? You are requested to calculate. I have already calculated before, so I am getting 5.36 into 10 to the power 3 mole. Now the question is, you see this much is extra compared to this value. So number of mole of hydrogen, the given value, this is the given value and this is the required value. Try to understand the difference between the two. This is that much is required and that much is given. So obviously what is going to finish first? Hydrogen is going to finish first. So since the required amount is not there, so hydrogen will be limiting reagent. So we need to understand this particular problem. Again, I am telling you what we have done. Since one was given in gram and another was given in kg, the best way to do is it is 1 mole is to 3 mole. It is 1 mole is to 3 mole. So better you take the molar ratio. From there, the given amount of nitrogen is actually how much mole? The given amount of hydrogen is how much mole? Then we have calculated that the amount of nitrogen which is given will react with how much of hydrogen. That is the required amount of hydrogen. But actually the amount of hydrogen according to the calculation we are getting is this much. So this is actually given and this is actually what is required. So obviously given amount is lesser than the required amount. So this will be finished first. That is why it is called the limiting reagent in this particular type of problems. So I request you and I ask you to solve the similar problems from the NCERT book so that not only NCERT, whichever sources you would like to solve, you can solve so that to clear the concept.